Yeah. So good evening. So we are going to continue what we have studied last class. We have done the problems with related to the CC amplifiers. Problem was a common collector amplifier is constructed using an NPN bipolar transistor and a voltage divider biasing network. So the value of R1 is 56 kilo ohm, R2 68 kilo ohm, and the supply voltage is given 12 volts. Then you had to calculate the base voltage, collector voltage, and emitter voltage. Yes, the
Yes, sir.
and then emitter current as well. And the internal emitter resistance Re dash. What is internal emitter resistance or Re dash? Can anyone tell me?
Sir, 20.3 ohms, sir.
No. I'm telling what do you mean by when I'm talking about the small notations of Re dash or internal emitter resistance. I have told you something which is it's something related to the supply, AC supply, DC supply, or something and all.
It denotes the AC configuration, sir.
AC configuration of the particular thing. So here I am talking about the AC particular supply of AC voltage of the or AC resistance of that emitter resistor. Clear?
Yes,
And
sir.
then you have to calculate the
Voltage gain.
voltage gain. Voltage gain is nothing but the output voltage and input voltage when a load resistance of 47 kilo ohm is used. Now when I was talking about the common collector, so we have the load resistor as per with if I'll consider with respect to my C configuration or common emitter amplifier configuration, I was having the particular separate load resistor, but
Yes.
here I do not have any separate load resistor, which is so I will consider my resistor which is connected to the emitter will be considered as a
Load
load
resistance.
resistor. Clear? So this
Yes.
is from here we can find out what is the we'll just replace the value of load resistor in place of your Re. Clear? And from there you can find out the values. Now we'll just see the solutions. So what is the first thing you have done? You have found out the current. So this is the basic steps I shown you. So from there, those who have not understood or by directly you can by using the Ohm's law. By using the Ohm's law, you can find out the base voltage. What is the base voltage you got? Please cross check your values whether you got the same value. 6.5 volt you got.
Yes, sir. 6.48 we got. Correct, sir.
Yeah,
Same.
6.48. So the first decimal number digit. So you'll
Yes,
get
sir.
the 6.5 volt. What about the emitter base?
Emitter base.
Emitter voltage. And then you have
5.78, sir. 5.
5.78. So it is nothing but 5.8 volt. Yes.
Yes, sir.
Then what is CE? Common the voltage common emitter configuration. If I want to take it, what it will be, VCC minus VE, it will be 6.2 volt. Okay, forget about that. So now emitter current, if I want to find out, can I find the emitter current? Sorry,
Yes, sir.
what is the emitter current you got?
1.23 milliamps.
1.23 milliampere. So and then AC emitter resistance. So AC emitter resistance, what I have to do, I have to use what?
Uh,
Voltage
Re-
divided by current. But voltage, which voltage I have to use?
silicon transistors value.
Yes, the normal silicon transistor voltage, which is nothing but 25 millivolt by divided by IE. So here you have to remember that whenever it is nothing but AC emitter resistance, whenever it is AC parameters is asking, you have to talk about the AC parameters. So here, if I am talking about the AC resistance at the emitter terminal, I have to use the Ohm's law only. So am I using the any other law? No,
No, sir.
I am using the basic Ohm's law, but what I am giving here, what is the voltage I am giving? 25 millivolts, which is nothing but a silicon voltage divided by IE. So you will get the what is the AC resistance, emitter resistance I will get at the emitter terminal. Yes.
Yes, sir.
So I get 20.3 ohms. Is it correct?
Yes, sir.
Now in this circuit, which is nothing but the common collector configuration, I was talking about the gain. So what was the gain formula? Gain formula is with respect to my AC and DC input signal. Yes.
Yes,
Or DC and input resistance. So I can find out AV is equal to V out by V in, which is nothing but IE into RE divided by IE, RE dash plus RE. Whereas this current and this current is nothing but what?
emitter current.
What can you tell me what exactly specify?
Low.
There's some look at the notations. Look at the notations. See, when I was just we'll go back 1 second. Yeah. So here you can see that here I am using capital IE. Yes.
Yes, sir. Yes, sir.
So IE, what is the E I am using? It's a capital form, correct?
Yes, sir.
But what I am using here?
Sir, small current, sir.
So no, small current.
Internal.
What do you mean by I and small emitter? Small denotions. Okay, so fine. Okay, if you have done this, what is the output? What is the gain voltage you got? What is the gain voltage? Anyone calculated gain voltage?
Sir, 652 volts. Will get.
Gain voltage, how you will get in volt?
Oh.
Gain voltage will be nothing,
Gain.
no units.
Yes.
So I got AV is equal to RE divided by RE plus RE. So because I do not have any other terms, yes.
Yes,
So
sir.
I got the 99.6% of the AV. I got 99.6% gain, which is very high gain, yes.
Yes, sir.
So from that I can make it out the gain of the amplification. So my signal, whichever I have produced as an input signal, it is giving me the highly gained amplified signal. Yes, that will be the conclusion I can make it out. That is the conclusion I can make it out. Yeah. So yes.
Sir, small RE dash means internal resistance, no, sir. Then
internal resistance, but with respect to which signal? AC signal.
AC signal, sir.
Yes.
So small IE also, small E symbolizes current, AC current.
AC current.
Okay.
Which we are not finding, correct?
Yes, sir.
Which we are not finding. So that's why for gain, what I used something which I already have.
Yes, sir.
So I have the emitter resistance and then AC resistance. Yes.
Yes, sir.
So with respect to that only, I can find out the gain. So that's why in gain we had 3 formulas. We have different formulas. Yes.
Yes, sir.
So here I will get cancelled. Yes.
Yes, sir.
So what I will left with? RE divided by RE dash plus RE. Yes. Agreed?
Agreed.
Yes. So hope the question is clear and everyone tried what exactly we have to do in this particular problem. Yes. Okay. Okay.
Yes,
So
sir.
what was the last portion of this question? The last portion of this question is also draw the final circuit and corresponding characteristic curve with the load line. Now, whenever we have studied that whenever we draw the characteristic curve of CC amplifier or CE amplifier, we have certain points called operating points, Q point, which is and then DC load line. There are 3 the characteristics. So whenever we have the graph, we place a line, slanted line, where your point or voltage is active. Wherever your point and voltage is active, that will be called as your Q point or operating point. Yes.
Yes, sir.
So that's what the circuit or the graph expected in this question as well. So now what about the circuit? Anyone has drawn the circuit?
Yes, sir.
How many of you drawn? Please raise your hand. Only 2 people. Okay, people are doing that. Okay, great, good. So we'll see what exactly the circuit is. Please. We know that the circuit of that individual, like the voltage divider portion of the base terminal, will remain
same, sir.
Yes, will remain same. Only what the circuit will remain same. Only what will change? The values are changing in that particular circuit, because now we have the values of R1, R2 and RE as well. Yes.
Yes, sir.
So I guess there is a this one is there. So it is nothing but 56 kilo ohm, 68 kilo ohm, and 56 kilo ohm, 68 kilo ohm, and 47 kilo ohm.
Yes,
okay.
Sir.
So from here I can find out what exactly my circuit diagram is and how my circuit diagram is happening and what is happening in my NPN CC collector amplifier transistors. Yes?
Yes, sir.
Fine. Now, okay. So what about this? I'll just enlarge that circuit. So from there I can find out what is happening in my VC. So VC, with respect to VC, what is happening? As my VC is changing, my IC is collector current is
decreasing.
So I can find out. So what is the operating point? We find out. We had a formula. Remember?
Yes, sir.
We had a formula last time. With respect to that, I can find out what is the operating point. Over there, I can find out that is the point and I can draw the line. That will be my particular operating point. Clear? So
Yes,
any
sir.
graph, you have to make it out what is happening with respect to my VCE. VCE is nothing but the output I am collecting, and IC. Q is the operating point or operating current. Or so from there I can draw the graph. Okay.
Yes, sir. Yes.
Can we take another example of it?
Yes, sir.
Yeah. So I'll use the same collector amplifier circuit which is given in above. Now what I'll do, I'll calculate the input impedance of the transistor base and amplifier stage if the load resistor RL is 10 kilo ohm and NPN transistor current gain is 100. So NPN transistor gain, I got what last time? 99 point something.
99.6, sir.
Now the current gain is there. AV is already given. Oh, so yeah. So now current gain is given. What is current gain?
Sir, output current by input.
Output current by input current. Now resistor, load resistor is given. Load resistor means the
RE,
resistor. Whereas remaining thing will remain same. And then you calculate the what will be the output or what will be the answers for all this. The same parameters you have to calculate in this circuit and in this example as well. Clear? So note down this question and practice this. Okay.
Input impedance we should find in this, sir.
Input impedance. What do you mean by input impedance?
Sir, Z
you have impedance thing, we have load impedance thing, we have studied. Impedance is one formula only. There's only one input impedance we can find out directly. So input impedance is with related to the bias resistance. Resistance is parallel to when your resistance is parallel. So all the resistance, whatever is there, R1 and R2, with respect to R1 and R2, you have to find the what is the bias resistance first. So first you have to find the R bias. Okay, first you have to find the R bias. So R bias is nothing but parallel configuration of R1 and R2. So you, R1 and R2, if I'll take it as in parallel, so what I have to do, what is the formula I'll get? R1 into R2 divided by R1 plus R2. Clear?
Yes, sir.
So from there, if I have the, so you can say that my impedance input impedance can be called as R bias is parallel to the impedance base impedance. So how you will find the base impedance? Base impedance formula is, I'll just recall, base impedance is equal to Z base. Write down Z
beta
base.
into RE.
Beta into RE plus RE dash. So
Beta
emitter
RE
resistance plus the AC internal emitter resistance.
Sir,
I'll
beta
recall,
into emitter resistance or beta RE dash plus RE dash.
capital R
Yes,
E, capital R E plus small r e dash. Clear?
Yes, sir.
That is your
The input impedance.
no, that is your base impedance. Z and subscript you have to write
Z in base, sir. Z in base, sir.
Z base, yeah, Z base you have to write. Okay, so transistor base impedance, which always we call it transistor base impedance, Z base. Okay. So what will be the input impedance now? Input impedance is equal to R bias is parallel to Z base. R bias is parallel to Z base. So what is R bias? Both the R1 and R2 is in parallel. Find out with respect to that R bias.
Yes.
And when your R bias is parallel to Z base, again, you have to R bias into Z base divided by R bias plus Z base.
Yes, sir.
Clear?
Clear.
Okay. So next we will move what all the applications we have for the CC amplifier. So this amplifier used for the impedance matching circuit. It is used as a switching circuit, the high current gain combined with near unity voltage gain, and it is also used for the circuit isolation.